All right. This is section 3.4, exponential and logarithmic equations. The essential question for this section is going to be, how do I solve logarithmic equations? We made a video for this because many of you like the videos for the other sections, and frankly this section is quite long, and you might benefit from having the ability to rewind and replay as much as you like. So here we go. So the first type of problem we're going to see is what happens when you try to solve exponential equations when they have the same base. So we have a property that says if b to the m power is equivalent to b to the n power, then the two exponents have to be equal, or m has to equal n. So let's see that in action. So for example 1, part A, we have 2 to the power of 3x minus 8 is equal to 16. Now, what we notice here is both of these don't have the same base, but what we can do is we can rewrite them. So for letter A, 2 to the 3x minus 8 is equal to 16. We can rewrite 16 as 2 to the 4th power. So now we have 2 to the power of 3x minus 8 is now equal to 2 to the 4th power. And using that property that was on the previous slide, we can now say that 3x minus 8 has to be equal to 4. And now when we just solve this very simple equation, we get 3x is equal to 12, and x has to be equal to 4. And there's our final answer. Alright, now for our second example. So it's a little different, but it's pretty much the same thought. So part B says 27 to the power of x plus 3 is equal to 9 to the power of x minus 1. And what I see here is 27 and 9 definitely aren't the same base, but I remember that 27 cubed, or 3 cubed is equal to 27, and here 3 squared is equal to 9. So I can kind of rewrite these. And what I can do here is I can write 27 as 3 cubed, put that in parentheses, and still raise that to the x plus 3. I can rewrite 9 as 3 squared and raise that to the x minus 1. And now our properties of exponents tell us that I need to multiply this 3 by both of these and this 2 by both of these here. And I get 3 to the power of 3x plus 9 is equal to 3 to the power of 2x minus 2. And now I have the same base on both sides of the equations. So now I could just equate 3x plus 9 to 2x minus 2 and quickly solve this equation to get x is equal to negative 11. Okay. So this is checkpoint 1. I would like you to take a few minutes and solve both of these. So go ahead and pause the video, and then after you unpause it, you'll see the solutions. Alright, so for checkpoint 1, part A is 5 to the power of 3x minus 6 is equal to 125. And again, these weren't the same bases, so 125 is the equivalent of 5 to the 3rd power. So this allows me to equate 3x minus 6 equal to 3, and through fairly simple algebra, again, it's 3x is equal to 9, or x is equal to 3. And for the second example, 8 to the power of x minus 2 is equal to 4 to the power of x minus 3. So now we had to convert, so not the same base, so this gets converted to this 2x to the 3rd. The 4 gets converted to 2x squared, and then we had to multiply our exponents together to get 2 to the power of 3x plus 6 is equal to 2 to the power of 2x minus 6. And then through simply equating our exponents again, we're going to get x is equal to negative 12. So the first example basically showed us what can we do when we have the same base on both sides of the equations. Now we're going to look at what happens to when we don't have the same base, or if only one side has an exponential equation. So the steps here are basically to isolate the exponential expression, take the natural log, and we're always going to use the ln for these, and then simplifying using these properties. These are the properties you wrote down in section 3.2, and then we're going to solve for the variable. So if you want to take a second and write these down, feel free to pause the video and then start it back up when you're ready to see the next example. Okay, so for example 2, part A wants us to equate 4 to the x power is equal to 15. So we need to solve for x in that. And there's no way that 15 is going to somehow be expressed as a base of 2 or a base of 4, and that's the only options for 4. Okay, so what we have to do now is let me start by writing the problem out. So for part A, we have 4 to the x power is equal to 15. So the problem already comes with our variable term isolated, so now all we have to do is take the natural logarithm of both sides. And we just very simply do that by writing the ln in front of both of these terms. So the ln of 4 to the power of x equals to the ln of 15. And now what we can do is we can use our power rule and move that x to the front. So we can write x ln 4 is equal to ln 15. And now we can divide both sides by the ln of 4 to get x is equal to the ln of 15 divided by the ln of 4. You could leave it like this, but the optional step is to go ahead and put it in your calculator, and we'll just put it to like 3 decimal places. So the ln of 15 divided by the ln of 4 is equal to 1.953. And I'll circle both of them because both of them could be expressed as our final answer. So for the second one, we can do the exact same thing. So if we have 10 to the power of x is equal to 120,000, we can rewrite this and take the ln of both sides. So this becomes the ln of 10x is equal to the ln of 120,000. Okay, and then move the x down in front like we did in the previous question. So x is equal to the ln of 120,000 divided by the ln of 10. And in our calculator, that gives us 5.079. Now, I wanted to let you know that that's not exactly how the book did this. What the book did is saw that this is a base of 10. So what they did is they took the log of both sides, and let me just kind of write it down here in black. So they took the log of 10x and the log of 120,000. And because it's base 10, we're able to just say x is equal to whatever log base 10 of 120,000 is. And you'll get the same answer. So it's still 5.079. I go ahead and always use the ln function because it's always going to give me the same answer, and I don't have to concern myself with which logarithm am I going to use, log base 10, log base 4, but the natural log always gives me the right answer. It just might sometimes create an extra step. Alright, so this is checkpoint 2. I'd like you to go ahead and work it out on your own, and then unpause the video, and then you can see the solutions. Okay, so letter A is 5 to the power of x is equal to 134. So if we, again, take the ln of both sides, we're able to take that x, put it down in front, and now we can divide the ln of 134 divided by the ln of 5, which gives us 3.043. Okay, so for part B, I've showed you both ways. My preferred way of just taking the ln of both sides And again, so the process is the same. So it's just eventually, as you follow it down, you're going to get x is equal to the ln of 8,000 divided by the ln of 10, which is 3.903. Where the other option is just take the log of 10 on both sides, where the left-hand side just becomes x, and then in your calculator, if you do log base 10 of 8,000, you also get 3.903. Okay, for this problem we have the equation 40 times e raised to the power of 0.6x minus 3 is equal to 237. So the first step here, it's important, we need to isolate the e by itself. So we need to do some algebraic manipulation before we take the logarithm of both sides. So the first thing I want to do is I'm going to add 3 to both sides. And of course that gives me 40 times e to 0.6x, which is going to be equal to 240. And then we'll divide by 40 on both sides, giving me e to the 0.6, x is going to be equal to 6. Okay, and now we can take the natural log of both sides. So we can do the ln of e to the 0.6x is equal to the ln of 6. And of course that gives us 0.6x ln e is equal to the ln of 6. And then please remember, the ln of e is equal to 1, so that goes away. So we're left with x is equal to the ln of 6 over 0.6. And then using your calculator, this is equal to 2.986. Okay, I'd like you to pause the video here and take a couple seconds to solve this equation, solve for x, and by the time you resume, you'll see the solution. Okay, so here you can see the solution as it's worked out. So we started by moving the 5 over to the other side, which made 63. And then I divided both sides by this 7, which gave just e to the 2x on this side and 9 on that side. And then the process is exactly the same. ln on both sides, leaving the 2x in front, and remember this is 1, so that doesn't matter, giving us giving us x is equal to the ln of 9 over 2, or 1.099. Okay, so the final example for this part is going to be, what do we do when we have two bases that are clearly not the same? And there's going to be a lot of algebra involved here. So because both sides are simply isolated, we're just going to start by taking the natural log of both sides. So here, if I do the ln of 5 x minus 2 is equal to the ln of 4 raised to the 2x plus 3. This gives me, of course, and what I want you to pay close attention to is when you bring the exponent down in front, because it has pluses and minuses, you need to write it in parentheses. So it's x minus 2 ln 5 is equal to 2x plus 3 ln 4. And now, everything needs to be distributed out. So I need to multiply the ln here by both of these terms, this ln here by both of these terms. Okay, and in doing that, I get x ln 5 minus 2 ln 5 is equal to 2x ln 4 minus 3 ln 4. Okay, and now in order to solve for x, we need to take everything with x terms and move it to the left-hand side, and then everything without is going to be on the right-hand side of the equation. When I do that, I get x ln 5 minus 2x ln 4 is equal to 2 ln 5 plus 3 ln 4. Okay, And now when I'm looking here at both of these terms on the left-hand side, there's an x in common, so that can be factored out in front, giving me x parentheses ln5 minus 2 ln4, and the other side stays the same. Okay, and now we just simply, to get x by itself, we divide both sides by this, giving us x is equal to, and then our numerator, the right hand side stays the same, 2 ln5 minus 3, plus 3 ln4 divided by ln5 minus 2 ln4. Alright, the decimal approximation of this is equal to 0.808. Alright, please pause the video and attempt checkpoint 4. When you unpause the video, the solution will be displayed for you. Okay, here's the solution to checkpoint 4. Notice that, again, the process is the same. In this step, we took the ln of both sides. In this step, we used the power rule to put the exponents down in front. And then we multiplied out the exponents to the ln expressions. And then we basically just used simple algebra and solved for x. Alright, this concludes the first video, so when you're ready, go ahead and move on to the second.